In this video, I want to look at a couple limit problems that involve infinity. Okay, and we've got a couple problems in the course notes that we can see that kind of get us started on this idea. Okay, so I want to move to the next page and then start drawing some pictures and trying to do some limits. Okay. So a typical problem that can appear in section 1.8 could be, say, the limit as x goes to 0 from the right of, say, 1 over x. Okay? And this is a good problem to think about in terms of a table of values. You can try to graph it first, but I think the table of values would be a good place to start. Okay? So we know that we're computing a limit as x goes to 0. Okay? And we're specifically looking at x going to 0 from the right. So I need numbers that are getting close to 0 from the right. Okay? I'm going to choose numbers like 1/2. And I'm going to choose fractions because this will make it easier to see, but 1/4, 1/6. Okay, and let's see what happens there. So 1/2, 1/4, 1/6. Those numbers are getting smaller. But the function says to do 1 over 1/2, which is the same thing as 2. 1 over 1/4 is 4. 1 over 1/6 is 6. Okay? So can you see these numbers getting bigger and bigger and bigger? Okay? Let's keep looking. Let's keep getting closer and closer to 0. How about 1 over 100? 1 over 1,000? 1 over 10,000. Okay? And the function says is 1 over x, and x is a fraction, 1 over 100, so 1 over 1 over 100 is the same thing as 1 times 100 over 1. Multiplying fractions, you multiply across the top, 100 over 1, which is 100. 1 over 1,000 is 1,000. 1 over 10,000. 1 over 10,000 is 10,000. So can we see what's going on here? Can we see the trend? That the closer and closer we get to 0 from the right, the bigger the numbers are getting. And in fact, the closer you get, the bigger these numbers are going to be. Which is why in this problem we say that as x gets closer and closer to 0 from the right, we say that this function is getting bigger and bigger and bigger, which is what we mean by putting the infinity symbol there. Okay? Could you take a moment to try to complete the table of values as x goes to 0 from the left of 1 over x? Try to complete some of the table of values here. So you could pause the video and try to fill in that table now. Alright, so if you've had an attempt on this problem, I'm going to go ahead and put it in. I'm going to try to do numbers like x going to 0 from the left, so that would be like -1 over 100, -1 over 1,000, -1 over 10,000. And in which case you're going to get 1 over -1 over 100, which will be -100, -1,000, -10,000. In which case, I'm seeing that this limit, I'm going to take the limit leap now and see that as x gets closer and closer to 0 from the left, this function seems to be getting negative a really big number. And that's what we mean by negative infinity for the limit value. Okay? And those two values are clearly not the same, and so definitely we're going to say that the limit as x goes to 0 of 1 over x does not exist. Technically this infinity doesn't exist, but we're going to write infinity in these problems because that's a descriptor of how the limit does not exist. Okay? So that's where I think the table of values comes in really handy, and if you wanted to, create a graph, a plot of 1 over x, and you wanted to plot that, say, from values -1 to 1, so 0 is right in the middle there. There's a graph of your function. Okay. maybe -2 to 2. And you can see that as x gets closer and closer to 0, from the right, the numbers are getting on their way upward, getting really, really big. You can extend this plot in your mind. Plot range, if you say all. Right, you can see that the graph shoots up and its number is way bigger than 500. Okay? Now, let's try to answer another question about this limit. Okay, about this function 1 over x. Okay, let's use red. What do you think about the limit as x goes to a big number of the function 1 over x? Okay, in the book, when they say want to think of the biggest number they possibly can, they're going to come up with the concept of infinity. So when they write limit as x goes to infinity of 1 over x, they mean what happens to 1 over x as x gets to be a really, really big number. That is what is meant by the notation, the limit as x goes to infinity, okay, of 1 over x. Okay. And you can compute a table of values again for this function, for 1 over x. And as x goes to infinity, that's numbers like 100, 1,000, 10,000, and you just keep going. But you get 1 over 100, which is 0.01, 1 over 1,000, 0.001, and then 0.00001, something like that. But these numbers are getting smaller and smaller and smaller, and so we're going to say that the limit as x goes to infinity of 1 over x gets closer and closer to 0. Okay, and that's what we can see in this graph here, that this function, as the x values get bigger and bigger, the y values of the function seem to be coming down on the y-axis. So if we plotted this to say 50, right, we can see that the numbers as x gets close to 50, the y values are getting close to like 0.05. And then let's plot this out to 500. Right, you can see the numbers are getting smaller and smaller. They're getting closer and closer to 0.0005. So that limit as x goes to infinity goes to 0. And those are the basics of limits that involve infinity in some way.